before we build the calculator application, I would like for us to first build the numbers guessing game application, which is part of the official Rust documentation, part of their learning syllabus. This tutorial will help us build the foundation for us to be able to build a calculator in the next series. So this application will be a console application, meaning that we will interact with the end user via the terminal in the computer. Now, thus far in our learning journey, we've only printed information to the terminal, but in this series, we will actually read user input from the terminal. So the game is the numbers guessing game. We welcome in the user in the terminal here, and then we ask the end user to type a number between 1 to 5 in the terminal. If they type in 0, we tell them the number is too small. If they type in 100, we tell them that number is too big, and then ask them to enter another number. If they enter a word, also known as a string, we will ignore that string and ask them to enter the number again. Okay? So let's actually enter a real number. 1 is too small. Let's try 2, too small. 3. 3 was the secret number, and I won. And then when I win, the program will break out and stop operation and return to the give control back to the terminal. Okay? So let's get started. Let's go cargo, new, numbers, guessing, game. Okay? And cargo will generate the application for us. Let's go ahead and go in there. We have the user suspect. By the way, I am using a plugin on my terminal called Oh My Geesh. If you want your setup to be like mine, let me know in the comment, and I will help you. Otherwise, there are plenty of documentation out there in the wild on how to set up Oh My Geesh. Okay, I'm going to use VS Code, Visual Studio Code by Microsoft, because it's free and it's a pretty righteous IDE, integrated development environment. And I can open the IDE from the terminal by issuing the command code and then dot. If you need help setting that up, let me know in the comments and I will make a video about that. Otherwise, there's plenty of documentation in the wild. Let's take another look at the files and directories that Cargo generates for us. So the cargo.toml file, TOML, by the way, the TOML is abbreviation for Tom's Obvious Machine Language, or actually Tom's Obvious Minimal Language. It's kind of a tongue-in-cheek abbreviation, but it is actually the official words behind the abbreviation. It is just another configuration format. Okay, other languages have YAML, JSON, XML-based configuration. Rust has Tom's Obvious Minimal Language, or TOML. It is just to provide configuration for the application where we inject our dependencies and then additional metadata for the application itself. I'll keep that open for now. The cargo lock, for all intent and purposes, let's just say that the cargo lock is to maintain versions of the crates in our library, to maintain and lock in the current version. Okay. For example, if we were to import an external crate right now, it will be in the cargo lock and the version will be there, it'll be locked. The getignore file is part of version control in the get version control system for whatever code repository you want to use. We will get into version control later. The actual .getignore file is to exclude directories and files that we do not want to check into our code repo. Let's jump over to the source directory um, or folder. The reason why we refer to directories as folders is because back in the day, the icon for directories was a folder when we started using GUI, or graphical user interface. So hence, from that moment on, we also refer to as folders. Both terms are interchangeable and both terms are correct. So once again, let me go into the target. For the time being, just know that the target directory, the the executable and the statically linked binary lives in the target directory. Okay, there are also some build artifacts in there that are maintained by Cargo Package Manager. The ROS folder. ROS stands for Rust Language Server. At this stage of our learning, we can say that the ROS provides the IDE and other development tools with information about our Rust application that we're building. And that should suffice for the time being. Okay, so you guys might be wondering, well, I'm interested in building the next Facebook, or I want to build the next hit video game like Halo, or I want to build software for, fifth generation, sixth generation fighter jets, which has millions of lines of code. Well, this is where you start the journey to where you can do that. Okay, we have to start the journey somewhere, and we might as well start with the fundamental building blocks. So that's why we're doing this. Okay, let's go ahead and start importing our libraries, both internal core libraries, as well as external crates. Okay, so I put a comment in there. A single line comment starts with 2 forward slashes. Comments inside of a code file is to communicate between human beings to human beings inside of a code file. The compiler just ignore the comment, okay? Comment, once again, is for human to human information, or you can pass information to yourself or to your team members, okay? So that's single line, 2 forward slashes. Now, multi-line comments start with an asterisk, and then you can type in whatever comments you want on there on multi-line, okay? Now, in regards to comments, you can either have no comments, very terse comments, or a whole lot of comments. Well, if you have to pick between those three evils, I would err on the side of doing a lot of comments that make sense to people. Because later on, you can always shorten the comments to make it more concise. But you would have no clue, and other people would have no clue as to what's going on in the code or the app if you have very terse comments that doesn't make any sense at all, or no comment whatsoever. Okay? So let's go ahead and pull in a standard. No, that's not a sexually transmitted disease. Pull in the standard library input output. Okay. The use keyword is the reserved keyword in the Rust language to import either a core module or external module referred to as crates. The print line is an internal function to print text to the terminal, to the console. In the previous tutorial, for practice sake, we imported an external module to do that, but we can actually do that natively inside of the core module, okay? So why don't we go ahead and welcome in the user to this game. I'm gonna go ahead and just paste in this text so you guys don't have to watch me type. This will be a multi-part tutorial. I don't want this to go too long, so I'll just break it up into little digestible chunks. Okay, so now we are okay. We have the print line here. When I'm not counting in and out I/O quite yet, but so it's giving me that squiggly line. That means it's a warning. Hey, you declare something, but you haven't used it yet. It will still compile though, and I will prove it to you. Let's clear this out. Let's go ahead and go cargo run, which will build the app for us. Okay, and as you can see here, we get a little warning here that says, hey, you declare something, but you haven't used it. Okay, you imported something, but you haven't used it. But it went ahead and compile anyway, and you can see here, welcome to the guess the number game, okay, which is the static text that we printed out right here. Okay, so let's stop here for now, and then we'll continue in the next video. See you soon. Bye.